Hey, it's Mr. Allred, and I'm here, and we're going to simplify some radicals with some practice problems we have. The first one, A, here is 2x times the cube root of x to the fifth plus 6x squared times the cube root of x squared. These look different, but the thing that gives us hope is the first one has a cube root and the second one has a cube root. So as long as we can get the same thing under the cube root, maybe we'll be okay. So let's see here. First of all, are they in simplest form? Well, let's look at the first one, the cube root of x to the fifth. Well, if we said we wanted to see how many times 3 would go into 5, it would go one time. So that means there's an x that can be pulled out of there. And then when we multiply it back, there's a remainder of 2. So we're going to put an x to the first on the outside and an x squared on the inside. So with this one, the 2 comes down. There's already an x on the outside, and we're going to put another one. So there'll be an x squared on the outside. And then it'll be the cube root of whatever's left, which is x squared. That was the remainder. Plus, and then the second one, it's a cube root, but it's an x squared under there, so there's not enough to pull any out. We need groups of 3, but there's only 2 under there, so there's nothing we can do with that. So let's bring it down. 6x squared times the cube root of x squared. So let's see. All the root and variable parts have to be the same to be able to add them together. So in the first one we have 2x squared cube roots of x squared plus 6x squared cube roots of x squared. Something's not dragging over here. I think I may have frozen. There we go. So those are the same. So I have 2 things over here. I have 6 things on the other one. So I would have 8. Something's wrong here. Okay, 8. Give me a second to catch up. 8 of those x squareds, cube roots of x squared. So in looking at that, we had 2 on one side, 6 on the other. That gives us 8 total. So we were able to combine those 2 things that looked a little bit different into a single expression. Okay, the second one here, B, is the cube root of 54x to the 8 z to the fourth. So numbers and variables are handled differently. So first of all, let's look at tearing this 54 apart. So 54 might not be the most common number for you, but it is, I believe, 2 times 27. 2 is prime. 27 is 3 times 9. And then 9 is 3 times 3. So if we look at the prime factorization, 2, 3, 3, 3, it is 54 is a single 2 times 3 to the third. Well, we've got a cube root. That's important. And we've got 3 3's. So out here we can write a single 3. I'm going to leave some room just in case, and then it'll be times the cube root of whatever's left, which is 2. Now we still got to deal with our variables. So keep in mind, for the x's here, we're looking for groups of 3, and there are 8 available. Well, 3 goes into 8 2 times with a remainder of 2. So the 2 on top is the outside, and the 2 on the bottom is the inside. So we'll have an x squared out with the 3 and an x squared in with the 2. And then the last thing we have to worry about is the z to the fourth. So 3 goes into 4 one time with a remainder of 1. How coincidental. So the one up top is the outside and the one on the bottom is the inside. So we'll have a z on the outside and a z on the inside. So we'll have When we simplify as far as we can, 3x squared z times the cube root of 2x squared z. All right, thank you.